the fact that they can be taken apart and reused again every time, you know, you're reducing that impact. So what's the best way to reduce the impact of your solid floor? So Andy, we often get asked about solid floors. You know, renovation of a floor is a pretty common thing if you're renovating a whole building. We're trying to reduce the impact of that. Where do we start? Do we need a breathable floor?
Yeah, so firstly, our solid floor system, I mean, we have a way that you could renovate or retrofit an existing solid floor if the floor screed was sound and being retained, but the sort of more nuclear option of totally excavating the existing floor and putting something totally new in, you know, we have a lithoglass floor system. In a traditional sense, floor breathability probably was quite a useful function. You know, if you've just got a solid stone tile laid directly on the earth, you know, you've got ground moisture coming up, there absolutely is an interaction between the soil moisture content and the moisture content in the room.
Yeah.
Once you're adding insulation, you sort of change the physics of heat and moisture transfer there to some extent. We use recycled foam glass as a capillary break, so you can generally manage ground moisture with either a capillary break or a barrier. The issue with a barrier directly against the subsoil is there's a risk of displacing some of the moisture in the floor, and you generally, you know, the DPM layer, the barrier layer, is going to be discontinuous where it meets the walls, and that's a problem.
Yeah.
But with something like recycled foam glass, you've got a non-capillary, free draining layer. That is also your insulation. It's lightweight, it's low carbon to transport it, and it's taking material directly from the waste stream. So it's really useful, but we're not necessarily trying to invite the drying of the ground soils up and into the room spaces. So really useful layer for managing moisture and establishing some insulation. What are we looking at above that?
Well, so exactly. So once you've got your capillary break and the foam glass is completely reusable, you know, you compact it in. If you want to dig it out again, you can do. You know, there's no limit to how many times you can use it. But over the top of that, we're putting a vapor control membrane. It will also act as a sort of a damp-proof membrane as well, which keeps building control happy. But over that, we're using a leveling layer. We're using Kenwood, which is a mineralized wood chip, to get the surface nice and flat. Then we've got 2 layers of wood fiber board, and then we're on to the lithotherm. So the lithotherm is a screed replacement underfloor heating tile, but it's a tile, it's an interlocking tile. Again, it's all deconstructible. We put the underfloor heating pipes into that, lay them in there, and then we're putting a floating timber floor over the top. So whilst individually all those materials are relatively high embodied energy, you know, if you look at the EPD for foam glass or lithotherm, you know, there is a reasonable amount of embodied energy. The fact that they can be taken apart and reused again every time, you know, you're reducing that impact. So reusability really is a great way to reduce the impact of your floor.
And also reducing the impact of the construction process. I mean, if you think about a 60 to 100 mil screed, I mean, that's a huge amount of moisture that you're introducing, and that can be extremely burdensome on other components. You know, if you've got a timber frame construction with variable diffusion membranes, you know, you've got a huge amount of moisture coming out of that screed, which is opening up the resistance of those membranes.
But also screeds you can't reuse. You know, once that's down, that's it. If you ever want to change it, you have to dig it up and crush it up and put it in landfill or whatever. But you're producing an enormous amount of carbon producing that screed. So yeah, you really don't need it to support a domestic floor load. So why not make it deconstructible? Yeah,
and just one point on the membrane. The membrane, it is a vapor control layer, but it's really, I would say, less important from a vapor control perspective in this build-up. It's actually much more about airtightness, which is about comfort rather than about moisture control. So
exactly that.
Yeah. Very good.
Excellent.